You might have actually been able to do it, but you should have waited till today to go ahead. And here's what we're going to do today. We need to first talk about what are like terms. So let's make sure we understand fully what like terms are. If you have a like term, it's got to be fully matched up exactly the same. So like if I have a 5xyz, I can actually add that to a 7xyz. Since these guys, all you have to worry about are the variables matching up. If the variables are matching up, then you can do whatever this says. So 5 plus 7 would equal 12xyz. Notice it's like I'm counting. I still have xyz's. I still have xyz's. It's like I have 5 over here. I have 7 of these guys over here. When I combine them, I see that I have a total of 12xyz. Now, notice the coefficients didn't have. The only thing that had to match up was the variables. Now, just to push this a little bit farther. That's a 2. Are these like terms anymore?
No.
No, they're not.
No.
Who does that 2 belong to?
XY, 5xy.
No.
Oh, it's y then.
The 2 only belongs to the y. The square does not belong to the 5. It doesn't belong to the x. It does not belong to the z. So actually, all I'd have to do is have that, and then these guys would be like terms. So you're just looking to make sure that these guys match up. Are these guys like terms?
Yes.
Why?
They're the same thing, just in a different order.
And what allows me to switch this order back here if I wanted to?
Does it begin with a C?
It does, and ends in the unitive.
Commutative?
Yeah. So the commutative property says that, hey, because this is 7 times y squared times x times z, it's like when your teacher told you 3 times 2 is the same thing as 2 times 3, and you're like, yeah, so what, teach? Why does that matter? That's the skill you're activating actually right there that allows you to switch that order. So you could actually rewrite this as 7xy squared z. And since they match up, you can add those together. They are like terms. So the only thing you have to make sure when you're combining like terms is that each one of the variables matches up. So I have an x, or I have a y squared, I have a y squared. I have an x here, I have an x. I have a z, I have a z. Check, they're like terms. Now, please be careful. When we add things, right? It's like I have, if I had 5 fish over here, let's just draw a quick fish. Oh, that's terrible. And that's recorded. That's what I was going for. Oh my gosh. It's hard to write with this pen. I'm blaming it on the pen. Shut up. I know you guys are laughing at me. You should be. All right, let's say I have 2 fish, or I'm sorry, 4 fish over here, and 2 fish over here, only because I don't want to draw any more. How many fish do I have total? You would say, hey, 1, 2, 3, 4, 5, 6. You would have 6 fish. You would not have 6 fish squared or any of that crap that kids try to do. I've seen kids do this. If I have 5 x's, I add 4 x's. They love to make this 9x squared. That's wrong. You have 5 x's, you add 4 more x's, you have 9 x's total. Now, the reason why they get that screwed up or mixed up is because this problem, which we're going to have to do, when I have a multiplication between them, this turns into, again, really this is 5 times x times 4 times x. And what did we just say, Robert, about multiplication? What can we do with it if it's all multiplication?
Commutative.
And so what does that mean? I can reorder the x and the 4 so I can put it like that. And what happens when I have 5 times 4?
20.
And then what's x times x? X squared, because what we say when we have the same base and we multiply them is we add their exponents. So 1 plus 1 is a 2. So if I had 5x squared times 4x to the third, I can just multiply the 5 times the 4, which is 20, and then the x squared times x squared makes it become x to the 5th. Does that make sense?
Yeah.
We're going to need to know how to combine like terms and how to multiply them. Notice when I multiply them, right, what didn't matter? What didn't matter when I multiplied them?
The exponent of the
Right.
variable.
Are these like terms?
Yes.
No.
Oh wait, no, the exponent's different.
Right. If I couldn't add them, but I'm not adding them because I am multiplying them. I can actually multiply them. So that's what, like we said, would become 20x to the 5th. So what I mean by that is if I have 5x x and I times that by 4y, can I multiply them? Heck yeah. 5 times 4 is 20, and then you just write xy behind it. However, if someone asks me to take 5x and add it to 4y, I can't add those. They're not like terms. That's as simple as that gets. So you need to see the little differences. All it is the dot in the middle, right? Everything else is the same in these two equations. 5x, 5x, a 4y, a 4y. The difference, the operation between them. You cannot do anything with it. That is the final answer. 20xy, that's the final answer. So the reason we're doing that is because we're going to get problems like this. And in this case, do the parentheses matter?
No.
Why not?
There's an addition sign between them.
Because this is an addition sign. Now, do not get this confused with multiplication sign in between them. We would handle that completely different. Because this is an addition sign, I can actually just drop my parentheses. And when I go to add like terms, by the way, if I call your name and you do not respond to me, you will be getting kicked out of the class. I'm tired of too many kids who I can sit here and ask and they don't respond to me. You can respond to me via voice or chat. I don't care which one. I prefer voice, but we have the chat function there. So if you don't have a microphone, there's no excuse not to answer me. And if you get kicked out of class, I will probably change your attendance to absent because I have a feeling there's too many of you who are logging on and walking away from the computer. Just want to make sure that that's heard. Are there any things, Destiny, what would I add together first? By the way, we do the highest exponent first. So what would I put first? What can I combine?
6x cubed and 2x cubed.
Okay, and this is a positive 6x cubed and a positive 2x cubed. Those are going to make more. So what am I going to have?
8x cubed.
Yes. So 8x cubed. Perfect. Thank you so much for your help.
You're welcome.
Ashton, what would be the next thing I want to combine?
X squared negative 8 squared.
Yes, so this is a positive x squared, which is how many, Austin?
What, Austin?
Or sorry, Ashton.
2 x's.
No. How many of these do I have?
Oh, 2.
Mm-mm.
What do you mean?
There's no number written in front of this.
So just 1, right?
Right, I have
I thought you meant
1.
x's.
No, sorry, I got you. I have 1 x squared. Okay. I have negative 8 x squareds there. When I put those together, what do I have?
Negative 7x squared.
Perfect. Thank you for your service. Tucker. What would that be the next thing I'd write?
1x.
Where do you see the 1x?
I meant the 4x.
Okay, so you meant the x to the first power is what you
Yeah.
meant, I think?
Yeah.
Okay, so what, so you would say the 4x, does it have anything else in common?
No, I don't think.
No, there's not. There's no other thing. See, everything else is marked off. The only thing that's left is a 7. That doesn't have an x. And a 3. That doesn't have an x. So this guy is kind of all by itself. So it doesn't have any common terms. So I just write the plus 4x down there. Does that make sense? And then finally, Daniel, what do I have last that I need to put together?
Negative 7 and 3.
And what happens when I put a negative 7 and a 3 together?
You get negative 4.
You do get negative 4. And that would be my final answer.
Mhm.
Does anyone have questions on what we just did there? Next one. So it's paying attention to these little details. That's why I talk so much, is because I'm trying to show you the little details, the differences between the problem I just did and the problem that I'm doing now. What's the major difference between this problem and the problem that I did just a second ago?
We're subtracting.
And so what does that mean?
Drop the bracket.
We need to distribute the subtraction sign between the last parentheses first.
Yes. So this right here is what I need to do first. Oop. Once I do that, what can I get rid of? Once I decide that I'm going to distribute this negative, what can I drop?
The parentheses.
Yes. What is that negative sign going to do to everything behind it? What is this negative going to do when I distribute it? It's only going to do one thing.
Switch the signs.
That's all it's going to do. Now, please be careful. Do you see that plus 3x? I understand that that is behind the subtraction sign. However, you do not distribute the negative to it. Once the parentheses are closed, the negative stops distributing. So this would stay a plus 3x. Does everybody understand what I am talking about?
Yeah.
This would change
Yeah.
signs, this would change signs, this would change signs, this would not. The parenthesis is closed, that means you stop your distributing. So this would be a negative 3xy, this would be a positive 2x squared. And if this was in the original problem, it would still be plus 3x, but it's not there. I just wanted to give you that because I've seen kids make errors on that kind of stuff. They keep distributing that negative. When the parentheses close, you stop. All right, here we go. Eric. Eric. Uh-oh. Eric, I'm going to have to kick you out. Okay. All right, Madison.
Would we do the 3x squared y squared and the negative 2x squared y squared?
Yes, we would. And I love how you said that because you said it perfect. Some people want to read this as 3xy squared. And if I wrote that, that would be this 3x squared, or 3xy squared would look like this. So you read that perfect where you said 3x squared, y squared. That's exactly how it should be. And you are correct. These two are like terms. And if I combine those, Madison, what am I left with?
Just x squared y squared?
Right. And when you say x squared, y squared, that how many of those are there?
1.
Right. And a positive one of them. Perfect. Thank you so much, Madison. Jonah. Jonah, what would be the next thing I would combine? So, Eric, Jonah. If you don't know what you're supposed to do next, it's okay to tell me that, but we need to talk so I can teach you. If you're not responding, like I said, I'm assuming that you are no longer at your computer, and I just don't want you in the class if that's going to happen, because I want to have, when I talk to parents about what's going on with your grade, I have proof of what's going on. So Jonah, I'm going to have to kick you out if you can't answer, bud. Noah. Noah Brown.
Yeah.
Tell me, what do you think? What do you think that we can combine next?
You already have the XY, don't you?
Yeah, so can you see my screen?
Yeah.
Okay, so this, we just combined this and this. So this is left, this is left, this is left, this is left.
You could
So
do the 6x squared and the 2x squared, couldn't you?
Okay. Yes, we can. That's fine. And by the way, we'll talk about this at the end. So if you did this, what's the 6x squared and the 2x squared? What does that become? Do you know how to do that, Noah, or no?
No.
All right. Seriously, think about it like this. If I have 6 puppies and then in another room I have 2 puppies, how many puppies do I have total, Noah?
8.
I have 6x squared here. I have 2 more x squareds here. What do I have? Listen to the wording. Same thing. 6 puppies, 6 x squareds. You have 2 x squareds. How many do you have total?
Well, if you're saying 6 puppies plus 2 puppies would be 8 puppies.
So what would be 6x squareds and 2 more x squareds?
8x squared.
Yes. When you are adding, you are just counting how many you have of them. You have 6 of these right here. You have 2 more of them right here. You have a total of 8 of them. Notice they didn't change. It didn't become puppy squared. It doesn't become x to the 4th. It just is 8x squareds. Noah, does that make sense? Because we need to make sure we can add like positive and negative things. And since it was a positive 6 and a positive 2, I got 8 of them.
Correct.
Okay, help me with the next one, Noah. It's the same thing. Do you see this right here? What is this term?
I need to see where your mouse went. Where to go? Oh, yeah, that's the 12xy squared.
It's a 2. Sorry, I know that's
2xy squared.
good. And
Negative 3xy squared.
xy squared, right?
Yeah.
Well, I have 2 of them here. I take away 3 of them. What does that mean I have?
Negative 1xy squared.
There it is, dude. Do you see why it's important to talk to me? Because we can clear things up so you can do your homework tonight and it shouldn't be too hard.
Extremely. Thank you.
Does that make sense?
Yes.
So please ask me questions. No, if you're sitting there and you see me doing something, I don't mind explaining it to you guys, but I cannot see your, this is even harder. I tell my kids when they're in class, listen, I'm not a mind reader. I can't tell if you understand it or not. The only thing is in class, I can kind of see their faces. And I don't know if you've ever seen someone who has a question on their face, you can sometimes tell. So I can be like, wait, you don't understand. And I can call on them. I can't see your guys' face. You got to be so mature. So
Mr.
ask me
Mark.
questions. Yes.
So this is all the homework's going to be on, just what we've been doing. That's it.
Yep. This is combined terms. I got a couple more things to show you, but not too much.
Okay.
Ashton.
I gotta go take a test at school for my 7th period. Is it okay if I leave right now?
Yes. Remember, I'm just go back and finish watching it.
Yeah.
You should start watching it about, I don't know, 15, 20 minutes in and see, just remember that last question and get to that.
Yeah. Okay. Thank you. Bye.
You're welcome. Bye. Good luck. All right, so the next thing that we need to go over is when we do this, which this should be, again, fairly similar to stuff that you've seen. We are just doing it with maybe more variables, but you should have kind of seen this. Right here, this is just going to be distributing, meaning everything in the front bubble has to multiply by everything in the back bubble. So I'm going to multiply this 2m by 3 things. 1, 2, 3. I'm going to take this and multiply it by 1, 2, 3 things. So when I do that, right, I do 2m times 3m squared. That's that one where I'm thinking like this, 2m times 3m squared. That's what I'm doing. So 2 times 3 is 6. M times m squared turns into m cubed. Does that make sense?
Yep.
So I'm going to keep doing that. I'm hopefully not going to have to keep drawing the arrows. I'm going to do 2 times this. 2 positive times a negative is a negative. 2 times 4 is 8. And m times m is m squared. 2m times 2 would be a positive times a positive is a positive. 2 times 2 is 4. And m. Now I move on to the 5. 5 times 3 m squared to a 15 m squared. 5 times negative 4 m is a negative 20 m. 5 times 2 is a positive 10. Now we do our combining like terms. There's nothing that combines with this, so I have 6m cubed. This and this combine, I have negative 8m squareds. I'm adding 15m squareds, and so the positive and negatives cancel each other out. And when I finish the canceling out, I'm left with 7 and positive m's left over, and those are m squareds. I have positive 4m and a negative 20m. 4 of the m's cancel 4 of these out, leaving me with negative 16m, and then plus 10. And finally, mn plus 1, mn minus 2, and mn plus 4. Do not freak out. Do not try to attempt to do more than one bubble at a time. So what I'm going to do is I'm going to multiply this times this, distribute it, and kind of ignore this for just a minute. But I'm not going to forget about it. I'm just going to ignore it for a little bit. So I'm going to multiply this times this, which gets me to m squared n squared. This times this, which gets me to a negative 2mn. Positive 1mn. And then this times this, which is a 2. And at the end, I'm going to put the mn plus 4 back here, but I'm not doing anything with it yet. This does not have a like term, so I'm going to go m squared n squared. This right here combined gives me a negative mn and then minus 2. I am now going to distribute that to that one that I ignored. So once I multiplied these two and then I simplified it to this, now I'm going to multiply this times this. You see how I'm only doing 2 bubbles at a time. And again, since there's 3 in this first one, I'm going to multiply this times 1, 2 things. I'm going to multiply this by 1, 2 things. I'm going to multiply this by 1, 2 things. So mn, or m squared n squared times mn turns into m cubed n cubed. M squared n squared times 4 turns into a positive 4 m squared n squared. A negative mn times a positive mn turns into a negative m squared n squared. A negative mn times a positive 4 turns into a, whoops, it's a good thing I said that out loud, a negative 4mn. A negative 2. A negative 2 times mn turns into a negative 2mn. And a negative 2 times a positive 4 turns into a negative 8. Final step is to combine like terms. That has nothing. The first one has nothing like it. So 3 m cubed n cubed, done. You notice how I mark them off? That's so when I look back, I make sure I used them all and I didn't forget anything. This right here combines. I have 4 of them. I'm taking 1 away. So I have 3 of them left. 3 m squareds n squareds. I have a negative 4mn, a negative 2mn, so that gives me a total of negative 6mn, and finally a negative 8 by itself. And there's my final answer. Does anyone have questions on what I just did?
Can you go back to the, like right after you did m squared n squared minus 2mn plus mn minus 2, and then in parentheses mn plus 4?
Yep, right here.
Could you just go through that one more time?
All I did is, do you see these guys I distributed, right?
Yeah.
Then what did I do from here to here? Do you see this right here?
Yeah.
What do you see about it with this guy right here? What are those 2 things called?
Like terms?
And I combined those, so I had a negative 2. I added 1, that got me a negative 1 of them.
Okay.
That's the only thing I did from that step to that step. I just combined these 2. If you notice, look,
Oh, okay.
that's still the same. That's still the same, and that bubble's still just right there. So I just combine these two.
Okay.
So I distribute, after I distribute, combine like terms. Okay, I distribute, that's what got me here. Okay, combine like terms, that's what got me there.
Okay, thank you.
You're welcome.